Your monthly Bedrock bill just spiked 15x higher than projected. Your application logs show about 200 tokens per response, but CloudWatch metrics reveal nearly 2,400 tokens per invocation. The delta is invisible to your app layer. The root cause? Bedrock Agents runs an internal React-style reasoning loop that burns tokens for every step, deciding which action group to call, interpreting Lambda responses, and iterating, none of which appears in your final response. On a typical 3-step task, the agent consumes roughly 2,400 tokens per call, but you're only metering the 400-token final answer. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Amazon Web Services Bedrock Guide. Amazon Web Services Bedrock is a managed service that lets you call foundation models via API without provisioning any infrastructure. You pay per token, and Amazon handles the GPU fleet. It supports models from Anthropic, Amazon, Meta, and more. For simple tasks, you use InvokeModel. For complex workflows, you use Bedrock Agents. Model IDs like Anthropic, Claude 3 Sonnet 20,240,229 v1, 0 are versioned. Always pull them from environment variables so upgrades don't require code changes. Also, set explicit timeouts on your Bodo 3 client. Without a read timeout, a slow model can hang your web workers indefinitely. Here's the standard setup. We configure the model ID from an environment variable, set timeouts, and enable adaptive retries. This client will be used for all Bedrock API calls. When calling Claude models, you must use the message's API format with the Anthropic version field. Always capture the input and output tokens from the response. This is your cost telemetry. And handle throttling exception by raising a clear error so you know when to request a quota increase. This function calls InvokeModel to summarize a document. Notice we return the token counts, essential for monitoring costs. The temperature is set low for deterministic output. For user-facing apps, streaming is critical. Instead of waiting for the full response, InvokeModel with response stream sends text chunks as they're generated. The user sees text appearing almost instantly, but your load balancer's idle timeout must be high enough alb defaults to 60s, which will truncate long completions. This generator function streams a support response. It yields text chunks as they arrive. Notice we skip non-text events and handle the message stop event for metrics. The generator plugs directly into a fast API streaming response. Bedrock agents extend a single LLM call into a multi-step workflow. The agent receives a task, generates a plan, then executes it by calling Lambda functions or APIs. Each reasoning step and tool call burns tokens, often 10-20x what the final response suggests. This is the hidden cost we saw in the hook. Action groups are Lambda functions that the agent can invoke. The agent sends a specific event structure, and your Lambda must return a precise response envelope. If you miss a field like message version, the agent silently fails or hallucinates an answer. This Lambda handles an order lookup action. It parses the agent's request, fetches data from DynamoDB, and returns the required envelope. The agent then uses this data to formulate its response to the user. This is the same issue we highlighted at the start. Here's exactly why that happened. Each step in the agent's loop triggers a new LLM call, and each call includes the full conversation history plus tool definitions. A 3-step task can consume 8,000 tokens, but CloudWatch only logs the 200-token final response. The rest is invisible. The fix is to meter actual token usage from the agent's CloudTrail events, not from application logs. Set up a CloudWatch metric filter on input token count and output token count. For simple queries, bypass the agent and call InvokeModel directly. It costs 1/10 the tokens. This is the incident from the hook. Bedrock agents consume 515x more tokens than CloudWatch logs show. The logs only capture the final response tokens, not the intermediate reasoning and tool call tokens. Always monitor via Cost Explorer, not CloudWatch logs. Knowledge bases use embeddings models that have cold start latency. If your embeddings model hasn't been invoked in 15 minutes, The first query can take 2-4 seconds. Pre-warm with a cron job every 10 minutes or use provisioned throughput on the embeddings model. The default TPS quota for most models is just 5 requests per second. That's fine for DMOS, but with 50 concurrent users, you'll hit throttling exception almost immediately. File a service quotas increase at least 2 weeks before launch. Never set max attempts 1 on a streaming client. If a chunk fails and Bodo 3 retries, it restarts the stream from the beginning, but your client already received partial output. You get duplicated content. Handle retries at the request level instead. Bedrock Knowledge Bases gives you managed RAG. Upload documents to simple storage service, and Bedrock handles chunking, embedding, and retrieval. The Retrying Generate API does retrieval and generation in one call. You can customize the prompt template to enforce answer style. This function queries a knowledge base. It retrieves up to 5 relevant chunks and generates an answer using Claude. The custom prompt ensures the model only uses the retrieved context. The response includes citations so you can verify the source. Identity and access management permissions are your primary cost control. Scope every policy to specific model ARNs and use condition keys to enforce cost center tags. The Amazon Web Services managed policy Amazon Bedrock Full Access is for DMOS only. In production, it lets any engineer invoke the most expensive models. This policy restricts Bedrock access to a single model and requires a cost center tag. Any request without the correct tag is denied. This prevents accidental usage of expensive models and makes cost attribution straightforward. The article uses Anthropic version, Bedrock 2023-0531, which is required for Claude models on Bedrock. However, older Claude v1 v2 models use a different text completion format, not the message's API. If you switch to a legacy model ID, the request body must use prompt instead of messages, or you'll get a validation exception. Always check the model's documentation for the correct API format. The article mentions the rigid response envelope for Bedrock agents, but doesn't show the exact structure. Here's a minimal valid response that the agent expects. Missing any of these fields causes the agent to silently hallucinate an answer instead of using your Lambda's result. Bedrock agents have a fixed session timeout of 1 hour. If your use case requires long-running conversations, e.g., a support bot that remembers context across days, you must implement custom session management. Store conversation history in DynamoDB and inject it into the agent's initial prompt on each new session. The agent will not retain any state after the session expires. To debug token costs, set up CloudWatch metric filters on input token count and output token count from Bedrock's CloudTrail events. Use the Amazon Web Services CLI to query logs and correlate token usage with specific agent invocations. Always compare against Cost Explorer for the real bill. Let's run through some common interview questions. What is Amazon Web Services Bedrock? Managed inference proxy for foundation models, pay per token. How do Bedrock agents multiply token costs? Each reasoning step and tool call adds LLM invocations, often 10-20x the final response tokens. When would you avoid Bedrock? Needs sub 100 ms latency, models outside catalog, or virtual private cloud-only data processing? And a few frequently asked questions. How do I reduce Bedrock costs? Use InvokeModel for simple tasks, monitor via Cost Explorer, scope identity and access management policies. What's the difference between InvokeModel and agents? InvokeModel is single-turn. Agents orchestrate multi-step workflows with tool calls. Can I use Bedrock with my own virtual private cloud? Bedrock processes data on Amazon's infrastructure. For virtual private cloud only, self-host on SageMaker. To recap, Amazon Web Services Bedrock simplifies GenAI deployment but introduces hidden costs, especially with agents. Always meter token usage, scope permissions tightly, and choose the right API for your task. Thanks for watching. Ready to go deeper? Up next, Amazon Web Services Snowball, data migration, edge computing, and physical data transport, then introduction to Google Cloud Platform, then Google Cloud Run Basics. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.